Any announcements before lunch? Any announcements from the organizers?
Lunch is...
Questions.
is
People have to get vouchers again. Explain how it works for lunch.
to my knowledge, your lunch, you just take your badge and you show it. You go to the bottom canteen, the one on the ground floor, and you take your food and you show this to the cashier. And then you take your food and your plate and you go upstairs. So no vouchers, nothing. Just show this badge and they'll put it on our card.
The places are reserved upstairs, so please go upstairs with your lunch.
Maybe before lunch you want to hear my talk, but it's up to you. It's up to you. It's okay. It's next. It was on the. I don't know where it is. So.
That we didn't want.
But you can. It's on the program, yeah.
There's another session.
There's another session.
Okay. Never mind. You can go for lunch if you're hungry. So don't worry.
Okay, we'll get it.
Oh, I have a USB key for this, if you want.
Yeah, it's here. This, no, this one.
Yeah.
Yeah. Sorry about that, Doug.
Well,
It's all right. Just to make you more hungry.
There you go.
okay, after a somewhat dramatic intro, and my apologies for that. Now I'm ill-prepared, but give me a second.
Well, my name is Antonia.
We're hearing Antonia on MX Cube all-in-one user interface control and collaboration.
Well, this morning I was listening to problems, people getting together, or having the same users which they don't want to program, and also being a friendly user interface and so on. So I'm going to present MX Cube, which is specific for the MX beamlines, but it may eventually answer some of your questions. That's why I put it all-in-ones, because it's many things when you talk MX Cube. So that will be my presentation. It's MX Cube in general, then how the collaboration works, and then some insights for developers. That's what we need to control. And MX Cube stands for Macromolecular Crystallography Customized Beamline Environment. I stress again, it's for the macromolecular crystallography because they have very standard beamline interfaces, so you can automate a lot of things. So they have 2D detectors. The problem there is with that it's fast, and we have different vendors for those detectors. We have diffractometers, which need to perform multi-axis movements, and we have in these diffractometers also visualization and beam shaping devices. And we have robots because we want to go fast and we want to go automatic. And those robots allow us to be very autonomous, but also we have different vendors for those controls, those robots. So if I have to say what MX Cube is all this. It started like providing common user interface for all the crystallographers, no matter where they are. Because here at ESRF we have 7 crystallography beamlines. They are slightly different from each other. And there are also crystallography beamlines. The same users, they go to different synchrotrons, but it's very useful to have the common user interface. So that it has some intrinsic data collection methods, because the collection is quite standardized. So we can use them to give them a very friendly user interface. There is you see all the oscillations. The last one, but not the least, is the seriocrystallography, which we have a specific beamline even for this. And there is a poster upstairs if you want to see more details on this. So what we need and what we have in MX Cube is that we have something for the users which is easy to use, which is very robust, and we want the users to have a very fast learning curve because we cannot train them so often, and this is a lot of constraints on the local contacts as well. And we also want it, as it goes from one synchrotron to another, to have to be control system agnostic, because all the different synchrotrons, as we heard today, have different control systems. And what we also want is full remote access. This has been reinforced by the COVID, but also the interfaces, the experiments, they're very fast. They can last just several hours, so it's a bit too tight the users to come, to put their samples and to go away. So remote control here is a must. And what is also important for us is that it gives a very high throughput, as we saw also today with Diamond. And we do a lot of automated data collections. There is one beamline which is specialized in automated data collection. And this year, on the 5th of December, we will celebrate its 10th year of operation. And just there is a slight difference between going fast and going automated and unattended. Here at ESRF, for example, we have the quality that goes higher priority than the speed. But the speed comes with it. And also, MX Cube is talking to a metadata catalog, which is LIMS. And tomorrow, you'll hear a talk from my colleague Marjolaine Baudin to see how it communicates with this metadata catalog. And also, because they may be standard, but there are still different techniques, and especially the scientists come with new ideas. We are also giving a link to external workflow engines so they can give their own how to go. And somehow different is that it's a platform sharing because we are different institutes and we have also different backgrounds. So we can talk on this. We can share our specific domains and go to a common solution. And also, this also brings to best practices because we have to go all in one place. A little bit of a history. It's been designed at ESRF first, as you see, long time ago. And at the time, it was Python by Qt. Then all of a sudden it grew to a collaboration because people were interested in having the same UI. And then in 2015 we split into, for the UI, it's web and Qt. So we feature both. And just to tell that now it's our 4th version. A few words of what a collaboration is. And I call it a successful collaboration because it really goes for quite so many years now, and there are more and more people joining. So we started 8 synchrotrons, now we have 15, and not just 12 synchrotrons from 4 continents, but also we currently had a spallation source which joined us, so apparently it's good for them as well to have the same structure. What's a collaboration? Some of the things we picked up, like the structure. So that's something which really works, and you can find in different collaborations. As I said, we are platform sharing solutions. We have, as a collaboration, very established convention on how to develop, how to contribute. We share best practices. We share continuous integration, testing, linting. All this is a common thing in the collaboration. What's very important as well is that as there are scientists also in the scientific committee, we share a place where the scientists can express their needs and we can discuss on them, and there is a steering committee which decides what the priorities are. So they can decide that, for example, this serial crystallography is more important now, so let's put the effort on the serial crystallography. How it works, we have twice per year plenary meetings going on round robin between the synchrotrons. And we have regular developers meetings, which are once per month usually. You can find out a little bit more in an old paper of the Journal of Synchrotron Radiation. And this is where you can find information about the collaboration and how our meetings look like. So, a little bit more about the insights of the MXQ. It's an open source of LGPL license. We split it in two. I would probably say three even, because there is the library, which is the MXQ core. And there are two user interfaces based on web technologies and based on Qt. All the repositories are hosted on GitHub. And we also have quite big documentation on read the docs. Everything which is yellow is MXCube. There is the library, which is shared by the two user interfaces. The Qt and the web server are Python Python based, and there is also a user interface, a web user interface. You'll see a little bit more about it later. And there can be different control system and sequences. They all go to the same library. A little bit more about those libraries, the MXCube core. You can find the links if you want for the repository itself and for the documentation. The main goal of the library is to provide a software abstraction, a little bit like OFID, but not just for epics. And also, it defines a API for both UIs. It's 100% Python, and it's maybe not exhaustive list of everything which is already supported in MXCube. So if you are having one of those, you have a lot of things to profit from, because it's already inside. It's also easy to add new one if you have new control system or a new sequencer or new protocol. There are two ways of getting into this. There is one which includes the full control system, like for Bliss, and you also have channels and commands for more, like for epics, for example. It's a set of abstract classes. These abstract classes, they really give the abstraction of everything, not just the hardware, but also some protocols and so on. It makes it really easy to newcomer to step in, because you don't have to write a lot of things, you only write your specific part of the code. There is a queue mechanism which allows to make automatic data collection. And there are mockup classes and test suite and configuration examples. So it's quite rich. Excuse me. And it's built as a Python package, so you can pip install it if you want. Web, MXCube Web, again, the repositories. I've chosen just two snapshots from what the web is. This is when there is a visualization, and this is when there is a data acquisition. And this you can see in all the synchrotrons you go who run MXCube. Some features overview. We have login, so you know who you are. We have visualization, you have seen. You have a lot of data acquisitions, different, and also externally workflows, as I said before. We can handle samples, not just mounting and mounting, but also information coming from external system. For example, users who has put the information about their samples. It's synchronized with the user portal, so you can see immediately in MXCube what the samples are. We have a zero-code interface, not for everything, but just for simple dialogues, but still it's possible. And as I said, remote access, there is a handshake, so from all the users who are connected, there is only one who has the control. And there is also communication chat in the MX Cube, so users can give control, and they can also share information. So there may be one at TSRF and one at home, and so on. What is the technology stack? It's been about 10 years ago we decided on the technology stack, but you can find all the usual suspects. So I'm not going to put more information on it. It's just there is also a test suite, and we also have a mock-up application, so we can try immediately your new components. And just to conclude, it's a user interface, so the users are happy to have just one interface all over the place. It's a control which is system agnostic, so you can plug in a lot of different control systems. And it's a very successful collaboration because people are really talking to each other, they're sharing, and when we do, for example, the commits, we see each other's code and we discuss and we share. And I think everybody should go this way for collaborating because this saves a lot of work to everybody. And well, I know that you're waiting for this, but maybe you have some questions. And thank you for staying.
Thank you for the talk, and again, apologies for the huge bug on my side. You certainly had the better transition to lunch than I did. Do we have questions back there?
I'll meet you to save time. Cool, that was a great talk, thank you. From my vantage in the Blue Sky community, while users would like a consistent interface, we encounter a lot of diversity of strongly held views from Beamline staff about the details of the interfaces that they want. How did you succeed in the MX Cube collaboration in agreeing on an interface that people share? And how customizable does it have to be?
Well, I show you only one picture of our interface. We also have everything where the samples are and so on. But before going to see what you see, we spoke to first our scientists and then to scientists from the collaboration, and when they agree, then we implement things. And they also, with the workflows, you can share. You can plug in your own acquisition sequence without the others knowing it. But you don't. The UI is the same, so you just click on a button and by the way, we still don't have a publish button, but this is to go.
Thank you.
Okay, let's thank all speakers again. And enjoy lunch. And the poster session.